Assalamu alaikum students of Cambridge 911. Okay, so basically today we are going to discuss about the behavior of metals. In this unit, previously we have discussed the properties of matter, that what the properties the metal have. Now in this lecture we're gonna discover that what type of behavior does the metal have. So let's move with our lecture. Okay students, so basically there is a periodic table in this slide, so you can see that the metals are present from group 1 to group 12, as you can see. Okay, then there are some metalloids on the right, and as you move from totally right on the total right, then there are some non-metals. Okay, so the basically the group 1 is called alkali metals and the group 2 is called alkaline earth metals, and it usually consists of very reactive metals, and then in between the green color is showing the presence of the transitional metals. Okay, so these are the also metals, they possess the characteristic of the metals. Okay, so for example, if we talk about the alkali metals include lithium, sodium, potassium, etc. Then in group 2 basically there are the alkaline earth metals, which include beryllium, magnesium, calcium, etc. And then in group 3 basically there are some group 3 has aluminum and the most abundant metal in the earth crust in this position. And then in between we have some transition elements, and they all are metals, and they include most of the metals in everyday use. For example, it includes iron, it includes copper, it includes tin, it includes zinc, it includes lead, it includes silver, it includes gold, etc. Okay, so basically these were the introduction by using the periodic table. Okay students, so now we are going to discuss some reactions of the metal with water. Okay, now because this unit, the 13.2, is dealing with the reactivity of the metals, that how much a metal is reactive, to what extent a metal is reactive when it gets react with water or with the hydrochloric acid or any sort of acid like that, or with the oxygen as well. So we are going to compare the reactivities of the metal. So first of all we are going to take the example of calcium here. So calcium is very reactive, we can say, with cold water, and it form a moderately soluble alkali calcium hydroxide. Alkali means basic. Okay, as you know that there are two things when we talk about, so one is the acidic and the other one is basic one. So basically the basic substances are also called alkali, or you can say that the bases are also called alkali. Okay, so when the calcium reacts with cold water, it forms a moderately soluble alkali calcium hydroxide in a gas, hydrogen gas, and a white milky precipitate can develop as calcium hydroxide. So calcium hydroxide will be precipitate out as a white precipitate, you can say, and is only slightly soluble in water. So there is a equation which I have given to you all, that the calcium when reacts with water, so what it actually forms, it forms calcium hydroxide and hydrogen gas. Now remember that the thing or the substances which we write behind the before the arrow, these are called the reactants, and whereas the substances which we write right after the arrow on the right side, you can say, so these are called the products. So basically in the chemical reaction, the reactant and the products are the product are formed when the reactants reacts together. Okay, so in the reactant we are having calcium, and in the product we in the reactant basically we are having calcium and water. They are just mixing with each other, they are just reacting with each other, and a chemical reaction is taking place. And then finally what actually comes out as a product, we are getting calcium hydroxide. The formula of the calcium hydroxide is CaOH2, and a gas is also getting produced, and that gas is hydrogen gas. This is how the calcium reacts with cold water. Okay students, so the next reaction is the reaction of the metal with water. For example, we are going to take the example of sodium. So sodium is a very reactive metal when it reacts with water. So the sodium usually melts to a silvery ball and fizzes at a spin over the water. Basically it sometimes explodes like that. We can observe the explosion as well. The rapid exothermic reaction basically produce a colorless gas which gives a squeaky pop with a lit splint hydrogen. Okay, basically when the sodium reacts with water, so it explodes. Okay, and because the reaction is exothermic, and exothermic reaction are those reactions in which the heat is liberated or given out from a substance. So the universal indicator will turn from green to purple violet as a strong alkali sodium hydroxide is formed, and initially the sodium floats on the floats because it is less dense the water. Okay, then moving toward the equation, you can see that I have given the reactant as well as the product. Then in the reactant you can see that the sodium is reacting with water, and the in product you can observe that sodium hydroxide is getting produced as well as hydrogen is getting produced. Okay, so you have to remember that these two things usually get produced when sodium reacts with water. Okay, the sodium hydroxide which we get is the base. Sodium hydroxide is a very strong base. So because of the formation of sodium hydroxide, our solution will turn alkaline, or we can say our solution will turn basic. Okay, so this is what we discuss in the mentioned paragraph. Let's talk about the reaction of metal with water. For example, we have magnesium now. So the magnesium burned vigorously with bright white flame when strongly heated in the presence of oxygen to form a white powder of magnesium oxide. For example, when I have given you the equation as well so you can understand it properly. Magnesium when reacts with oxygen, it forms magnesium oxide. So the magnesium is represented as Mg and the oxygen is represented as O2. So when they combine together in a chemical reaction, magnesium oxide is formed, and the formula of the magnesium oxide is MgO. So this is the reaction which actually happens when magnesium react with water. So students, there is a reactivity series which I have shown you here. According to that series, there are certain different type. Basically it tells that all the elements, or we can say that all the metals are different from each other. Some are very reactive and some are least reactive, or some are in between, or we can say that they are moderately reactive. Okay, so there's a reactivity series. You just have to remember the reactivity series because it helps a lot during your examination. So in the reactivity series you can see that the most reactive metals are present at the top, whereas the least reactive metals are present at the bottom, whereas the moderately reactive metals are present at the mid or at the center. Okay, so for example, if I talk about potassium, so it is the most reactive metal. If I talk about sodium or calcium, these are the most reactive metals. But if I talk about silver, or if I talk about gold or platinum, so these are the least reactive metals. Okay, so basically I have added these for the comparison, so you can make the comparison by yourself also. So by looking at the reactivity series, you can just figure out that which element or which metal is more reactive, which element is moderately reactive, and which element is least reactive. Now we are going to discuss the reaction of metal with the hydrochloric acid. Basically, magnesium is very reactive with dilute hydrochloric acid. Dilute means in which the water is added in too much amount. Okay, when the water is present, basically there are two different type of solution, we can say that. The one is the dilute and the other one is concentrated. In dilute, the quantity of water is much more. Okay, and in concentrated there is no water, there is just a pure chemical, there is just the presence of pure chemical. Okay, so magnesium basically is very reactive with dilute hydrochloric acid, forming a colorless soluble, and it forms a colorless soluble salt which is called magnesium chloride and hydrogen gas. As you can see in the equation, then that the magnesium is getting reacted with hydrochloric acid and it's forming the magnesium hydrochloride and hydrogen. Okay, so the magnesium hydrochloride formula is MgCl2, and the hydrogen gas is also getting produced in this reaction. Now let's talk about zinc. Zinc is quite reactive with dilute hydrochloric acid, forming the colorless soluble salt called zinc chloride and hydrogen gas. In the equation you can see that the zinc chloride is getting formed and hydrogen gas is getting evolved. Let's talk about iron. Iron has a relative slow moderate reaction with dilute hydrochloric acid, it forms a soluble pale green salt, iron chloride and hydrogen gas. As you can see in the equation, when the iron reacts with the hydrochloric acid, it forms iron chloride, which is represented as FeCl2, and hydrogen gas H2 is produced. If we talk about lead, so it reacts very slowly and effectively. No such reaction, or we can say that real reaction take place with dilute hydrochloric acid or even dilute sulfuric acid. Okay, if we talk about copper, silver, gold, basically they has no such type of reaction with the hydrochloric acid or even sulfuric acid, because these are the least reactive, so they won't react at any cost with the hydrochloric acid or the sulfuric acid. Okay, so we can use any of the strongest acid, but nothing will take place, no reaction will take place, because they are the least reactive. So copper, silver, gold, basically these are the least reactive, so nothing gonna take place in the reaction, because they don't have the capability, they don't have the ability to react. Let's talk about when a metal does not react with water or hydrochloric acid, it actually drives out hydrogen and it takes place. This shows that the metal is more reactive than the hydrogen, and it has a stronger drive to form a compound. In case of silver and the copper, it do not react with water or acid, so they are least reactive, or we can say that they are very less reactive than hydrogen. Okay, so let's talk about the redox reactions. For example, if we talk about magnesium and hydrogen reaction, so this is a redox reaction. I have given you the ionic equation. In this reaction, you can see that the magnesium atom is getting oxidized, and the oxidation, basically when it is getting oxidized, so it is losing its electron to form magnesium ion, which is Mg2 plus, and the hydrogen ion forms the acid is reduced by electron gain to give the hydrogen molecule, which is H2. So you have to remember that the loss of electron is called oxidation, whereas the gain of electron is called reduction. In case of magnesium, the oxidation is taking place and it is losing its electron, whereas in case of hydrogen, the reduction is taking place and it is gaining its electron during a chemical reaction. Okay, students, so basically there are some practice questions which are given. These questions are question number 1, 2, 3, and 4, which are given on page number 181 in the fundamental chemistry book. So just go throughout. After listening and watching the lecture, just go through and read the book 13.2 very thoroughly, so just all the concepts get clear in your mind, and and try to solve these questions which I have given to you in the practice. And if there are some further queries, so then you can ask through emails or through the live meetups. Thank you so very much.